Trigonometric functions of angles in standard position. In this video, we will work on a problem that was solved as an example in the book. So I lifted this up from my book, Precalculus, example 2.5, Trigonometric functions of angles in standard position. So we have an angle beta that is in quadrant 1, and its terminal side coincides with the line y is equal to 2x. So how does this angle look like? Well, this is our Cartesian plane. This is the initial side, okay? The initial side of our angle. And the terminal side of our angle coincides with the line whose equation is given by y is equal to 2x. So what now? Find cosine of beta. Find cosecant of beta and find cotangent of beta. So right now, at this stage of our discussions about trigonometric functions, we only understood your sine, cosine, and tangent functions in relation to the ratio of the sides of a right triangle. And so you are wondering, how can we produce the value of cosine, cosecant, and cotangent when we are not seeing a right triangle here? Well, there is actually a right triangle here. So our terminal side coincides with the line whose equation is y is equal to 2x. You know, this point lies on the terminal side. Why? Because when x is 2, the value of y is 2 times 2, which is equal to 4. So this means that the terminal side of your angle contains the point with coordinates 2 and 4. And you know what? That point actually defines a right triangle. Okay, so pay attention to this. So the distance of point C from the horizontal axis is what? It's 4. So we can draw a vertical line to the horizontal axis. And at the same time, the horizontal distance of point C from the vertical axis is this one. It's equal to 2, okay? But that length is also equal to this, the distance of this point from the origin. And so with these figures now in our plane, you can now see that the point C with coordinates 2 and 4 actually defines a right triangle. So this right triangle has legs. The longer leg is equal to 4. This one is equal to 2. What about the hypotenuse? What is the length of your hypotenuse? Well, we shall compute for the length of this one. So what is the length of the hypotenuse? Let us call it r. R is equal to the square root of, 2 minus 0 squared plus 4 minus 0 squared. And then we shall get the square root of that. And what is that equal to? That is equal to, this one is 16, this one is equal to 4, so this one is equal to the square root of 20. And that is equal to 4 times 5, and the square root of 4 is 2. So the hypotenuse of this right triangle is equal to 2 times square root of 5. Okay? So let us show it. So now we have the right triangle. We now have the lengths for A, for side C, and then for the hypotenuse R. So we are now prepared to compute for cosine of beta, cosecant of beta, and cotangent of beta. Okay, so let us write down. So katoa, find cosine of beta. So we shall use your ka. Ka stands for cosine. A stands for the side adjacent, and H is the hypotenuse. If we were now to compute for cosine of beta, so what is the side adjacent? So the side adjacent is this one. Okay, it's 2 over, the hypotenuse is 2 times square root of 5. This is 1 over square root of 5. So how do you rationalize the denominator? What we do is we multiply by square root of 5 over square root of 5. And so this will give us a value for cosine of beta, which is equal to square root of 5 over 5. So that is our cosine of beta. What about cosecant of beta? What do we know about the cosecant function? The cosecant function is the reciprocal of the sine function. So let us first compute for sine of beta. Sine of beta is equal to the side opposite. Okay, this is your beta. So the side that is opposite to beta is 4. And our hypotenuse is equal to 2 times square root of 5. So this one is equal to 2 over square root of 5. So the reciprocal of that will give us our cosecant of beta, which is equal to square root of 5 over 2. Okay? What about cotangent of beta? So cotangent of beta is the reciprocal of your tangent function, TOA. Okay? Let us first compute for tangent of beta. Tangent of beta is equal to the side opposite. Okay, this is our beta. The side opposite, which is equal to 4, over the side adjacent, which is 2. So that is equal to 4 over 2, or simply 2. So this means that cotangent of beta, which is equal to the reciprocal of your tangent, is equal to 1/2.